Connect to the cloud. Okie dokie. We've already kind of started talking, but we'll get started with the proper class now. Welcome. I hope you all had a great day. Little admin housekeeping thing off the top before I forget. I went over the last sampling submissions, double checked the grading, made sure you guys made the changes requested. If you did not receive an email from me earlier tonight, then congratulations, you have successfully completed sampling all of the assignments. Really great work on that. Lots of fun to look over your answers for those and see how much you retained and applied the course content. The grading for this course, visualization, I'm just waiting for a few last marks to come in for last week's assignment 2, and then I'll send out those notification emails as soon as I have those grades. If you did ask for an extension, that's still fine. Just please make sure to get that submitted as soon as you can so that we can check it over, get you that feedback, and make sure that you're doing okay with this course. I see Cindy troubleshooting in the chat, so I will let you keep on doing that. Today's class. So yesterday we talked a lot about concepts, right? We talked about accessibility, advocacy in our context of data visualization. Today we're switching our focus back to application, so a whole lot of writing code. So again, if you weren't here a couple minutes ago, this is the right time to open up that Jupyter Notebook and get ready. It was in the chat before. Cindy's still there to help anyone, and sent it here. So run that one line that Cindy sent, and then you should be good to go for today's code. What's Serena saying? Yes, if you did not get comments or emails about sampling today, then you should be good to go. So if I did send you an email, it's saying that like you did not complete whatever assignment. So as long as you didn't get one of those, sampling is all done for you. You have completed it successfully. Any other admin type questions before we get into the fun stuff, the content? So assignment 1 is ongoing. So today is our last coding class. So after we finish today, after you submit today's code, then we'll be able to get you those final marks for assignment 1. So it's just an ongoing thing that we want to make sure you're coding along with us. Thank you. Good question. So as I mentioned, we're back in our coding mindsets today. Specifically, we're getting into some of our more advanced topics here. So we're moving a little bit beyond our basic matplotlib graphs that we've been making and modifying so far. We're going to explore new packages like Seaborn, Plotly for interactive viz, and we'll talk a little bit more about interactive and dynamic data viz, because like everything else, that's a decision that we want to make in an informed kind of way. We'll also talk about some qualitative data viz, like word clouds and Venn diagrams, also useful things to know how to make programmatically. Then if we have time, we'll cover tables in Python using plot table. That's just kind of bonus content depending on, you know, how many questions, how fast we move through this. Not the most urgent. I can share the code with us if we don't get to it. So we'll see how the class goes. A nice mix of concepts and coding for today. So to start that off, let's get into Seaborn. Some of you might have seen this used or even used it back during our very first class last week when we were exploring all of those different data visualizations from the Python Graph Gallery. Seaborn, really popular, very, very commonly used. So what it is a package for data visualization that is built kind of on top of Matplotlib. For that reason, it's really similar to Matplotlib, which is nice for us because we're still kind of working in a comfortable, recognizable space, but it does some of the semantic mapping for us in a really smooth, kind of automatic way. So if we recall, when I talk about mapping in the context of data visualization, I'm talking about taking which pieces of our data correspond to which visual elements on our plot. So again, with Matplotlib, we're saying this point is orange, this point gets this label, so on. Seaborn kind of does some of that for us in a very convenient way. So we're just going to go ahead and dive right into exploring Seaborn, seeing what we can do with it. The first thing we want to do, of course, is load up all of our packages. And note that we're importing Seaborn as SNS, just again, a little shortened, so it's easier for us to type and keep on typing and typing. So let me get myself a new cell here, and let's import all the stuff we're going to use today. So import Seaborn as SNS, import NumPy as NP, import matplotlib.pyplot as PLT, import pandas as PD, import SciPy, SciPy, import PIL, and import requests. And then this line isn't in the slide, but we're also going to set a random seed just to make sure that we're being consistent. And p.random.seed, we're using the lucky number. And then we'll run all of that. Thank you, Cindy, for the update in the chat. You guys can let me know with a little thumbs up to what I just sent once we're all able to get to this point together. And then we can keep on moving along. First couple of thumbs up. Good to see. Bunch all at once. Nice. Couple more minutes. Anyone with any questions or issues, let us know. I'll leave this up as I'm typing the next little part. One of the really, really nice things about Seaborn is that it comes with some sample data preloaded for us to use as part of it. So we're going to work with one particular sample data set. Again, because today's are more a little bit advanced topics, we're not just making, our one little string of data. We're going to work with something that more resembles an actual table of data. So the way that we access this sample data set is we say we want to load this data set into this object called tips. The data set we want to pull in from Seaborn is also called tips. And let's print it out and see what exactly is contained in here for us to work with. So again, we're making this object, which we're calling tips. And from Seaborn, we're going to load underscore data set, and then in brackets and in quotation marks, tips. And then let's print out this tips object that we made to see what it actually consists of. And so this, what we get is a data set about tips at a restaurant. So the total bill, how much the customer tipped, the sex of the customer, were they a smoker or not? So you can tell that this is some older data. What day they dined. I think the options in here are Thursday, Friday, Saturday, Sunday. The time, so which meal they went to, and then the size of their party. So how many people were dining at that particular table. So again, let me know if we can get that data set loaded. If you have any questions about what's going on here, what we're going to be doing. Nice, lots of thumbs up. All right. So we have our data. We'll start exploring Seaborn just by making a very basic line plot. All of our code here should look pretty familiar. These variable names that I'm pulling from here are just our columns from that tips table that we just loaded. Yes, in the chat. That is what we're going to be typing. So let's run this together and see what we're able to produce. So using Seaborn SNS, we want to make a line plot. The data that we want to use for that is this tips object that we just loaded, right? Our X variable is going to be total underscore bill, which is one of our columns from our table. Well, that pop up. And then our Y variable is going to be tip, another one of our columns from that table. And we run that, and we get this nice simple line plot, total bill on our x-axis, tip on our y-axis. Nothing crazy or particularly novel yet. If you have any issues, any questions that I can try to answer. I like the quick thumbs up. I think the intro to Seaborn, after doing Matplotlib first, I feel like it's kind of comfortable, like small changes, nothing too shocking. So sticking with that note, doing what we think, the same thing that we did with Matplotlib, get a little deeper, start modifying things. So just like with Matplotlib, Seaborn comes with some pre-made styles that we can use to change kind of the whole appearance of our plot in one little line. So let's go ahead and play with some of those preset styles just to see what happens to our graph. Up top, just by my convention, set underscore style, white grid. And when we run that, we can see that now we have, in fact, this white grid in the back of our graph. Some other options for us, we could do dark, so it gets this background. Oops, dark grid. You can get a darker grid. I think Pix is one. We get some tick marks on our thing. So again, different options. I think all of these ones look pretty clean. There's nothing too controversial. I'm going to stick with the white grid because I think it's a nice kind of standard. So nothing super groundbreaking yet. Seaborn does a whole lot of the same things as Matplotlib. We can change titles, axis labels. The way that we do these things changes just a little bit. So what we're going to do here is name this line plot that we made before. Now, instead of just writing this little chunk here, we're going to do that and we'll name that object tip graph. And then once we've made that object, we can say to that object, we want to set a title and an x-axis label and a y-axis label, and so on and so on. So let's try making those couple of changes to our code. So again, we have this line plot, the exact same one we just made, but now we want to say we're making that into an object called tip graph. And then to that object, we are going to set our, oh, I can't spell, title as tips versus total bill. Don't forget those quotation marks. We're going to set our X label as total bill, and of course include those units. And then our Y label is going to be tip amount, also in dollars. And now when we run that, we've added in our title and our axes titles with units so that we're clearly communicating these things to the audience for our data visualization. So you guys can let me know in the chat. Are we able to make this? Do we have any questions about what's happening here? Got 4 thumbs up. We're off to a good start. Okay. Looks like we're feeling okay with this addition that we made. Ooh, I spoke immediately too soon. Let's see what comes up here. Unexpected indent. Okay, so it looks like you might be missing, oh, you have a closed bracket up here where my mouse is. You want that closed bracket to be down here. So fix that bracket. You might have to fix the indent as well, but that should do it for you once that bracket is at the very end down there. Let us know if that works, but that should do it. Keep on pulling in our Matplotlib knowledge into Seaborn and seeing kind of how we can apply the stuff that we already know in this little new context. we can modify specific aesthetic elements of our plots. So we can set the size of our figure using plot.subplots, same as ever, again, because Seaborn is built kind of on top of Matplotlib, so some very similar language. We can also change different aesthetic elements in our line plot object. Again, I think a pretty similar, familiar language, color, line style, line width, things like that. So let's go ahead and add those couple of changes that we're making to our graph. So we want our figure size to be plot.subplots, fig size equals, let's make it 10 by 3, a little bit different for us. And then, whoops, over here where we're making our line plot, this is where we're going to change those different aesthetic features. Whoops, so still in our brackets, let's add a comma, and then we're going to say the color we want this to be is hot pink. The line style that we want is a dashed line. The line width that we want is 3. The marker that we want to use is just a circle. Our marker face color, let's make it indigo. And then again, we still want to keep those titles so that everything is nice and readable. And now with those changes, we've changed the dimensions of our plot. We've made dashed pink lines a little thicker, and we've also added indigo marker colors for our point markers. So again, the new things that we added here, we set the size of our figure, we changed some different aesthetic features going on. And again, none of this should be surprising. It's the exact same syntax as what we used in Matplotlib. So we should be pretty comfortable with that by this point. You can let me know in the chat if we're able to produce the same graph as me, if there's any questions, anything I can explain again or differently. Questions, thoughts as we're waiting for more thumbs up, more code to be written? Got an error. Let's see. Oh, they're so big. Where are you? Can I see the error message that you're getting, please? I'm not seeing anything immediately strange about this, but maybe the error message will illuminate that. Graph. There's something before the hot pink. Sorry, let me look again at your code that you sent. I'm not sure. Zindy, do you see anything causing the error?
No, I don't see anything at the I don't see anything that is very obvious. It looks good to me. I'll look closer to it.
Okay, thank you. So Zindy's gonna help you with that. If you guys can't figure something out, then come back to me and we'll try and revisit and I'll think of what's it. But I'm not spotting any like immediate typos or something like that. My default is always try to go through and like reload the previous code and see if that changes anything, but you guys are checking on that, which is wonderful. in the meantime. I didn't check how many thumbs up there are in the chat. Okay, it looks like we're mostly feeling good about this unless there are any more questions or issues. But this is the point where we've seen some Seaborn things, and it's where it's like, okay, Kira, but we can already do all this stuff with Matplotlib. Why are we bothering learning a new thing? Why is Seaborn actually an improvement or a change? So where Seaborn becomes really, really useful to us is when we want to add multiple variables to our plots using multiple different visual elements. So before, remember, we used Matplotlib to make completely different kind of plot objects if we wanted to have multiple colors on our graph or multiple lines. Seaborn lets us do that in just a couple of lines of code. So just for fun, we're going to change things up a little bit. We'll make a scatter plot instead of a line plot. We still want to plot the total bill versus tip amount from our tips data set, but this time we want the shape of our points to change based on the meal time, so dinner versus lunch. We want the color of our points, the hue, to change based on the day of the week. Again, both of these are variables from that table of data we have. And then we want to define, these are the colors that I want to appear on my graph. So let's try writing this all out, running it, and see what we're able to produce. So we're going to make this object called tip graph. It's going to be a scatter plot. The data we're using is still this tips data set. Our X variable is still total underscore bill. Our Y variable is tip. Now our style is that time variable. Our hue is our day variable. And the colors that we want to use for that hue, for those changing colors, we put in square brackets. And then we'll just type our color names, assuming that I can spell them correctly. So purple, hot pink, deep sky blue, and yellow green. And again, these are all kind of pre-existing colors with Matplotlib and Seaborn. Then we're going to tipgraph.set. Our title will be tips versus total bill. Our X label will be total bill in dollars, and our Y label will be tip amount in dollars. And assuming I typed that correctly, then what we get is this lovely graph where both the shape of our markers and the color of our markers are changing based on these two variables. So I'll scroll back up so you guys can see the code and type to where I am. So you found a typo. Oh, okay, perfect. I did not notice that at all, but I'm glad that you did. I'm glad you found that. You guys can let me know in the chat if you're able to get this, if you'd like me to explain again what on earth is going on with these new style and hue things that we've just been introduced to. Hey, we got our first thumbs up. Always nice to see. Any questions at all about what's happening? Do we feel like we understand the new stuff, how it's translating to our graph? So what we've got here. Typo. It should be style, S-T-Y-L-E up here. That should fix it, but let us know. Imra, let's see. Axes. Because you spelled label LE instead of EL for Y label. So make sure it's Y lab EL, and then you should be good. Thank you. Who am I missing? Okay, Serbi is here. Invalid syntax. Missing mark. So make sure you have your quote after hot pink, and then you should be all good there. That is for Serbi. Rochelle, if you can send a screenshot of your code that you're typing and the error message that you're getting. But from here, you have an extra E in your green. Just 2 E's for green. And then you should be good. I don't think I missed anything in the chat, but let me know. For the marker in the graph, is that a default style? You mean like these 2 particular shapes? So how would we get other shapes? Yes, so you definitely can get other shapes. I don't remember the word off the top of my head for what the syntax would be. If you remind me at not intermission, what's it called, at our break, I can look that up for you. Otherwise, Cindy, if you know the exact word, it's probably somewhere in the documentation. But short answer, yes, I'm sure you can set a palette for your markers as well. I just don't know what the word is off the top of my head. But remind me if you don't figure it out, and I can look that up for us. Anyone else? Questions, errors, requests for new explanations of what's happening here? I lost the thumbs up, but we have 11, so that's a good sign. Okay, we'll slowly keep moving along here. So again, hopefully we're starting to see some of like, oh, Seaborn is actually kind of useful. But let's keep building on that. Who's in the chat? Another error. Okay, let me look at this. Scatterplot data equals none. Do you need to reload the tips data set? Maybe. Tips doesn't have to be in quotation marks. Tips, so here you doesn't have to be in quotes. That should fix that. Okay, pair plot. I really like this feature of Seaborn. It's a really convenient way to compare multi-dimensional relationships between different variables. So let's say I'm really interested in exploring how the day of the week impacts all different kinds of interactions and characteristics of our data set. We can use our pair plot to explore all those different potential relationships in a really, really convenient, short way. All you got to type is that. So let's go ahead and do that. So from Seaborn, we want a pair plot. The data we want to use is our tips data set. The hue, the kind of variable that we want to compare by, is day. We run that and we get this lovely pair plot. And it gives us a collection of graphs that shows us how each of our variables relates to each other variable with our day differences highlighted by color or by hue for each one. So for example, down here, we can see how total bill relates to party size, so how many people are at the table. We can start to explore by the color of those points if there's any trends by day. Like maybe it looks like on Thursdays, bigger groups tend to attend, so something like that, right? Like letting us do that kind of exploratory data. The diagonal row kind of in the middle is what we get when each variable is crossed against itself. And it just shows us the distribution of values for that variable, again, by day, by our hue. So the code is up here. Did the data set contain only 4? Yes, it does. The data set only contains Thursday, Friday, Saturday, Sunday. Good question. So let me know in the chat if you're able to produce this. If you have questions about what we're seeing, I hope we can see that this would be a really useful thing for our kind of exploratory data analysis. So one of the most valuable pieces of advice that I ever heard as a data scientist is before you start doing calculations and trying to come up to exciting statistical conclusions with your data, put it on a plot, look at it and see if anything jumps out to you, any weird outliers or potential relationships. So this kind of tool is really great for that kind of exploration, digging into your data, seeing what you got. 6 thumbs up. We'll wait for a few more or for any questions or issues. It is cool. And that's the nice thing about Seaborn is like it's so quick to produce and it gives us a really nice kind of bird's eye view of, our whole table of data basically. So really, really useful for your own analysis and workflow. When would we use Seaborn versus Matplot? So if you're making something to like publish to share, it's totally your preference. You can use Seaborn, you can use Matplotlib. If I'm just doing exploratory data analysis for myself, like, I'm not trying to make this graph to share in a publication. I'm trying to make this for me to explore my data. I would probably use a pair plot or the next thing we're going to learn, just because it's kind of convenient one line. But for publication quality images, Seaborn or Matplot, it's your preference, whatever you like the best. Thank you. Good question. All right, for the next thing, I'm going to test you out a little bit. So pair plot, like we just saw, is comparing variable versus variable. If we want to compare specific levels within variables, so like specific categories within our variables, you could think of it. To do that, we do a rel plot. Before we go through this example together, let's challenge ourselves a little bit and our code reading intuition that we've been working on this whole time. Let's take, 3 minutes, go through this code that you see here. You can type it out, try it out. And then what I'm asking you to do is comment the function of each line. So what is each line here doing? And then we're going to go through it together and see kind of our intuition. Are we interpreting this in a reasonable way? So again, at 6:45, we'll come together, see what we were able to interpret from this code. But feel free to try it out, blank out certain lines, see how it changes your graph. Thank you, Cindy, for following up with that question. Already got one nice description of what's going on. If anyone else wants to share theirs, you totally. I'm going to go ahead and start typing out the code so we can go through it together. Right. It's 6:45, so if anyone wants to share their answers, you can. Just looking at what we have here in the chat, it looks like you guys understand this pretty well, what's happening here. Yeah, Rachel, it's for the customer, so the person who paid. But good question. That's not super clear from this. It would be interesting to see how the gender of the server affects tips. Cool. I like what you guys have here. as you guys said, we're not just comparing Dave versus Bill versus Tip. We're viewing the relationship between tip and total bill cost for each day. So each of our little graphs is a specific day. And then our color, our hue, says the gender of the paying customer. So kind of another layer of analysis happening there. And what this call wrap thing is doing, if we get rid of this line, yeah, okay. If we get rid of that, then we see that it gives us all of our 4 different columns, right? That's kind of hard to see. It's kind of expansive. So here we're saying, just wrap our columns for us into 2 columns to make our graph a little bit more compact, easier to read and engage with. I like these descriptions. Do we have any questions about this graph, this rel plot, relationships plot, and what's going on, when we might use it? Yes, all of these comments look really good that you guys are adding. And again, the purpose of this activity is for us, I want you guys to feel really confident in that based on what we've done with Matplotlib and now with Seaborn, it's not that hard, right, to look at a graph and understand what's going on, even if it's not code that we've particularly seen before. So we can make more and more complex graphs, but those little basic pieces are the ones that we've become familiar with. So we can do all sorts of things using those same pieces just put together in different configurations. So that's a pretty quick introduction to some of what we can do with Seaborn. Hopefully you can see some of where it might be useful in your work, your research. On this slide for your use after this class, whenever, there are a couple of resources linked that you can check out. We have a cheat sheet kind of PDF that covers the basics of Seaborn. We also have a whole section of the Python graph gallery focused just on Seaborn and plots made using Seaborn. So if that's something that you're interested in, tons of examples, sample code for you to take and modify for your own work. But now we can get on to one of the other advanced topics. I think it's something that a lot of people really look forward to in this class. We're going to talk about dynamic and interactive data visualization. We'll start by using an example to think about some underlying questions that we should be keeping in mind. And then once we have that foundation, once we have that kind of critical lens to use, then we'll start writing the actual code, because we can only write the code if we understand what we're doing, our purposes, our goals, and some things to be aware of. So the example visuals that we'll be looking at here are about gender bias in teaching evaluations. So some background on the issue in general. I guess the first thing to flag is that a lot of the studies in this area focus on binary gender variables, so male, female. They don't account for any non-binary professors or instructors. There's some interesting new research being done that accounts for the ways that these other identities on surveys can affect course evals and things like that. For now, we're just working with a couple of slightly older examples. So that caveat aside, the short answer is that the gender of instructors, whether it is their perceived gender or their actual gender, influences the way that they are scored by students on teaching evals, course evals. In general, student evaluations tend to be biased in favor of men and against women, even when all else is equal. We'll see a couple examples. And the stuff matters, right? Those student evaluations are used as part of tenure evaluations, as part of applying for promotions, for different things like that. I know here at the DSI, they certainly look at evaluations and consider who should we be rehiring to teach our next cohort of people. They always give me the suggestions when we have our meetings of like, here's what the last cohort said, here's some things that you can adjust or change. So these evaluations definitely really matter and impact people. So it's an important issue, right, if they're biased in one direction or the other. So here we have a graph from a published study on the topic. This plot is visualizing data about student ratings of male and female course instructors for an online asynchronous course. So because it was online, because it was asynchronous, for this experiment, students could be led to believe that a female instructor was male or vice versa, right? And what the authors ended up seeing was that regardless of the actual gender of the instructor, if they were perceived as male, students tended to rate them significantly higher. And I think this graph resembles a lot of the other graphs that we've produced and evaluated throughout this class, right? It does a pretty good job. It has our little error bars, labels our data so we can interpret it. It's a grayscale, but we can still kind of tell that contrast there. Relatively clear font. I had to blow up this image a little because it's from a PDF, but in general, a decent data visualization. The next one that I'd like us to consider, it's not from a peer-reviewed journal, but it is an interactive dynamic data viz. I'll put the link in the chat so you guys can open it up. And what it's doing is viewing the relative prevalence of different words or phrases in reviews of male and female course instructors on ratemyprofessor.com. So this one is fun. It's interactive, so we can type in different search terms. Ones that I always find amusing are if we type in smart, then we can see that our graph changes based on that word we're searching. We can see across the board, it comes up more in reviews of male instructors across all different subjects. We can see the number of uses and so on. Conversely, if we type in sweet, the exact opposite trend with a really marked gap, again, across disciplines to varying extents. So you can play around with this tool if you want. I think it's a fun kind of visualization way to dig into the data. But at this point, we've seen our two examples. Let's flex those data viz evaluation muscles that we've been building up throughout this course and compare these two images. So the first question that I want us to consider, how are they different? What is each of these things actually doing? So let me know in the chat or on the mic if you want. What are some key differences here? What is each one conveying to us, letting us do? Static versus dynamic, yes, absolutely. This one is a still image. The other one changes up. Anything else? What are the different things that they're doing? What is the different maybe purpose of each one? Let's specifically address the question of gender bias in instructor evaluation. There. One is more structured data, the other uses text info, right? So the underlying data is kind of different for each one. More details in the dynamic one. That's a fun point. I like that one a lot. Left visual is looking at the perceived gender. Right graph is evaluating the language. So the right adds more text compared to just numbers. Again, so getting at that different kind of underlying data that they're showing. So about the same broad topic, different underlying. Nice observations here. The one on the left is succinct and summarizes the topic. The one on the right lets us analyze relationships in a more granular way, for sure. The first one only shows one aspect of the evals. The second one gives more details. Again, specific facts, more interactive, so we can make our own decisions. Inna, I really like that point, and that's something we're really going to get into when we're breaking this down. Right, higher cognitive load. Another really valid point. Again, you guys are predicting my discussions, and I love to see it. On that note about cognitive load, interactivity, things like that, what do we think are some pros and cons of each one here? What's good about them? What's kind of not so good? What are our thoughts on these two? And again, you can base it off of stuff that we've discussed previously, like the cognitive load and so on. But we also haven't gotten too into dynamic data. So it can just be based on your own first impression and opinion on these graphs, if you like one more than the other. Right, more explorative, higher dimensional. Yes, I would definitely say that this one has room for some exploration. Do we think that either of these is better? Right provides more information. Ooh, that's an interesting point. I think this one might be arguable based on past cohorts. and their different opinions, because, you know, you could argue this one is telling you things about sample size and about averages. It's communicating something about error. So it's different kinds of information. But I see your point as well, this one, because you can search and come up with lots of different things. It feels like you're getting more info. Data left easy to read and compare at a glance. Totally fair point, right? This one takes a while to kind of get used to get the data that you want. This one, it is what it is. Again, everyone knows what a bar graph is. Left is more credible. Ooh, I like that point. That's getting back to what we discussed about provenance rhetoric, perceived trustworthiness, right? Because it's 2D, it's so simple, so on. Melanie getting into who do we think the audience for each one is, absolutely a salient point as well, right? This one is very conventional for like a report for other data scientists or researchers. This one is public facing. It's fun to play around with. Left peer reviewed. It does give that energy, yes, for sure. I like all of these opinions that you guys are putting out. Some really, really great observations and things that you're going to see in our next few slides. And it's important for us to consider those kind of micro level differences between static and dynamic data visualizations, because all of those changes have different effects, right, on our audience, the utility of our viz, and we want to think about them when we're deciding, should we actually be making a dynamic data viz? So just to kind of formally define our boundaries, our terminology that we're using here, when I say static data visualization, we are talking about an image-based chart or infographic, right? PNG, PDF, things like that. It is a snapshot of data. It's pretty much everything that we've seen so far in this class. Versus dynamic data viz, it's interactive. It's an application or a web page or something like that. It lets us modify and filter our data viz. It can tell us multiple data stories all in one visualization. So yeah, I like that point as well about Medium. We're going to get to something like that really soon, but that is a very, very relevant point. So I think dynamic data viz, they look really cool. That's one benefit, but there's also kind of more meaningful, salient ones. So dynamic data viz can provide info that we just can't get from a static chart, right? Think of the example we just saw. We can type in and search things and modify it. It's useful for viewing individual level data, right? We can get to that kind of granular level, as you guys are saying, for more exploration. It lets the audience dig into the data a little bit. It's not just an image, right? They can look for specific words. They can see how it changes if they change different features or select different things. This can give improved transparency and reproducibility, because they're not just taking our word for it, right? They can dig into the data a little bit by themselves, test out our conclusions. And then, again, seems a little superficial, but it's really, really important. A dynamic data viz can increase how much people want to be engaged or interested with this data, right? I know for me, if I have a choice of playing around with a cool dynamic data viz or looking at a bunch of pages of grayed out charts, probably playing with the interactive one is a little bit more fun to do, right? So dynamic data viz, tons of benefits, really fun to look at. But of course, that's not the whole picture. There's a tendency when you learn how to make dynamic data viz or animated graphs to want to use it all the time for everything. I was certainly guilty of this. The one that makes me cringe to remember, back in undergrad, I did a whatever research project and I made this unnecessarily just like 3D animated moving graph just because it's like, look at this cool data visualization thing that I can do. So I get it, because it's fun to be able to make that. But like everything else in data visualization, it's situational, it's context dependent. And if we use it in the wrong situation, it can be really kind of adversely impacting our ability to achieve our goal with that data viz. So when we're making a dynamic data visualization, it makes it a lot harder to tell a single clear story, to communicate one clear message, right? If we think to that static graph we saw, we can immediately see, oh, the perceived male approval is way higher, right? It tells that story, it makes our point for us. The dynamic one, depending on what we type in, it could tell a completely different story, right? We don't really have as much control over the narrative, the message of our visual. Because of that, dynamic data viz can be confusing or overwhelming for our audiences. I mean, just looking at this page, there's a lot going on, right? And when it's all moving around, it's a lot. Here we just have a search box, but what if we have a search bar and then checkboxes to say, do this or don't do this, or we have multiple drop downs that we can choose from. Again, thinking of our cognitive load slide that you guys invoked, when we're adding more stuff, we're forcing people to do more work. That can be a lot depending on who our audience is. And then, of course, another thing that you guys pointed out, dynamic data viz can be a little bit more challenging to share with people, to make accessible, right? If it's just an image, I can print it out. I can usually load it on my phone, on my computer, pretty much anywhere. Dynamic data viz, maybe it needs to be hosted on a particular platform or software. I'm thinking of those nice Power BI ones with the drop-down menus. Those have to be in Power BI, right? Or in the report server, something like that. This, if we print it out, we lose all of the impact. It has to be hosted in this particular way. So lots of different kind of challenges for us to consider once we stop being dazzled by the cool, interactive, moving pieces. So with that in mind, once we've kind of internalized all of that, we've considered pros and cons of dynamic data viz. Let's get into how we can actually go about designing them. So to start off, some preliminary questions that we should be asking ourselves when we want to make a dynamic data viz. Firstly, any interactive elements. So our search bars, our drop-downs, things to click on. Are they easy to navigate? Are they accessible? Just because it's a drop-down menu, not on our actual graph, we still want to be thinking about, is the contrast such that it's visible? What font are we using? How big is the font? All those considerations like that. A really big one is, how much time is our audience going to have to interact with this data viz? If I'm at this huge conference, I'm presenting in a hall of 200 other presenters, people have maybe an average of 30 seconds with each, poster or presentation. If it's the most complicated thing, tons of selections, no one's going to have time to explore the data visualization fully. So we need to think, can people meaningfully interact with this dynamic data visualization in the time or the space that they have? And of course, underlying all that, our most central question, do the interactive data viz features actually help serve our purpose? Does making our visual interactive help what we're actually trying to do, or are we just doing it because we think it's kind of cool to have an interactive visualization? So we really need to make sure that this is targeted. So in this case, it's appropriate because we want people to be able to search up different words to see that this trend occurs, across all different use cases. If I was just trying to convey a particular message, maybe the interactive feature wouldn't be the most helpful thing to my goal. Now, this word dynamic, it means that things are changing as we're looking at it. We can think of these changes occurring in one of two visual dimensions or categories. The first are spatial elements, and this is talking about position and quantity. So how many points are on our plot? What are the scales of our different axes? We can also think of retinal elements, size, brightness, rotation, color, shape, things like that. So in our dynamic data viz, are these two categories fixed or mutable? Can both of them change? Can only one of them change and the other one stays constant? Do the meanings of different features of these things change? And when we have in our head which of those elements is going to be changing, we can think of the kind of change process happening. So we'll walk through a couple of these, kind of in order from least extreme to most extreme changes. So identity preserving changes, we're still maintaining the associations between underlying data and our particular visual elements. Something is staying constant, predictable, right? And this is really important when we want people to be able to compare across different kind of snapshots of our plot. So let's say that they have, our plot of sales, and the thing that they can choose is what month to look at. If it's an identity preserving change, then maybe regardless of what month you choose, the sales for McDonald's are always in red, the sales for Burger King are always in blue, and it's just always those two companies, right? So I can choose January, I can choose February, and then I can compare those two side by side because the color is changing constant. The number of points is staying constant. The axes are staying constant, things like that. Getting a little more extreme, we can get into transitional changes. Here, some things are staying constant. Not everything is changing, but we might be adding new elements or changing things up a little. So we still want to be able to compare between our snapshots, but we're being a little bit more flexible. So let's say we're keeping our restaurant sales graphs. You can drop down, choose what month you're looking at. Let's say if we choose January, it shows McDonald's and Burger King. But if we choose February, it's showing McDonald's, Burger King, and Wendy's. So we have a new line, a new color. So we can still compare between our screenshots, but it's not quite so constant, right? Not everyone is going to have the exact same amount of data points or kinds of data points in it. And then the most extreme is an immediate change. Here we are not preserving associations. We might be adding new things. We might be changing up our scales, remapping our variables. So maybe the colors of our lines are changing. We're adding and taking away restaurants. Maybe in one of them, our y-axis goes from 0 to $1 million. In another, it goes from 0 to a billion. Because we're making all of these changes with each different selection, each different dynamic choice, we can no longer compare across those snapshots, right? If we take our January graph and our February graph, they're not comparable. The axes aren't the same. They have totally different kinds of data. So looking at them side by side isn't going to give us a meaningful comparison of our data. I'll pause here because that was a lot of concepts. Do we have any thoughts or questions about types of changes, the elements of our viz that are changing? Anything I can explain maybe differently? If we're feeling okay about these concepts, then the next thing that we have to do is to put it to the test and think about it. But I'll leave it up to you. Do you want to do the activity now and then take a break, or would you rather break than activity? Votes are coming in for break. Last chance if anyone wants to come with overwhelming numbers. I think not. All right, let's do our break now, and then we'll come back at 7:17, really dig into these changes, and then we'll start writing some code and actually producing these data viz. Yes, everyone go get your coffee. I'll see you in 10 minutes. Great job in the first part of class. everybody. It is 7:17. I hope we are all back and caffeinated. I also got more tea. Oops, let me remember to reshare. So as I said before, we talked about different things that can change in our dynamic data viz, different ways that they can change from kind of least extreme to most extreme changes. Now let's try to apply that new knowledge and come back to evaluating this dynamic viz that we looked at before. So what I'm asking us to consider is what kinds of changes are happening when we're interacting with this dynamic data viz? Are they identity preserving, transitional, immediate changes? What spatial and retinal elements are staying constant? Which ones change? These two kind of go together, right? We're looking at what's there, evaluating it using that new knowledge that we have. And then the last question is a little bit more creative. If you got to redesign this, would you change things a little differently? Why would you change it differently, or why not? Would you keep it all the same? Are there only certain elements? So let's take about 5 minutes so everyone has a chance to, play around with this page, find some answers to these questions, think of some answers for these ones, and then we'll come back together and discuss it before moving back into our coding, producing this stuff. Any questions before I let you work on this activity? (7:18) now. So at 7:23, we'll come back and we'll talk about this together. So good luck. I'm here if you have any questions in the meantime. (7:22). If you guys have your answers for the first couple of questions. We can consider these ones together because they kind of go together. If you feel like sharing those in the chat, that would be wonderful. Your answers to these first couple of questions here. I know there's still technically a minute left, but just giving everyone the heads up. All right, let's start talking about this together. Let's see what you guys thought. Both axes are changing. I'll get into your suggestions right after this, but I think they're good suggestions. Let's see. Data points are changing, write their location based on the search terms. X-axis scales change based on total word counts. Subjects get rearranged based on the order that they're in on our y-axis. Yes, absolutely. It would be interesting to see if there are any variations over time. I'm pretty sure the creator links the more background here. Maybe they talk about what they're doing and how they're selecting their data. I'm not sure. TBD. But valid point as well about the do we have clarity about where they're getting their data, what data they're looking at? Yes, absolutely. I would say if we're thinking about this chart of changes that are happening, I would lean towards, I think, calling this immediate kinds of changes happening because the scales of our x-axis are changing, right, with the different counts of things, because the order of things are moving around. I'm not sure how effective it would be to compare across different snapshots of this graph. It feels pretty extreme changes happening here. Like I know that the color of the male and female points are consistent. The meanings of each axis are consistent, but there's a lot of changes happening that I would call pretty immediate. I don't know if we could compare between one search term and the other. So with all that in mind, all of those wonderful observations that you guys were making, let's think about this one now. If we were redesigning this, what kind of different changes might we make and why or why not? So specifically thinking in terms of the dynamic interactive elements of this. Are there ways that we could improve that? I saw a couple of you. Anoop said, easier to visualize with a line or a bar plot. Totally fair. Working with our categorical data there. Anyone else? Any kind of changes that we would make to this? Again, thinking of our dynamic data viz, some of the pros and cons there. How can we make it a little better? Icons or symbols next to the subjects to make it more visual and fun. Totally fair. And again, because this is a very like public facing, right? It's not entering peer review. It's for people to use and experiment with data. In this case, I think that icons or symbols is it's a fun idea, right? Kind of adding to that very outward public facing vibe of this visual. Nice point. Anyone else thoughts on what you might change to improve this? Or reasons why you wouldn't change anything? I know for past cohorts, one thing that gets kind of controversial is with the on our y-axis, the different subjects with the order of them changing. So I understand why the order changes so that you can get that clean trend of like most to least words. I do think the changing order can make things slightly confusing and does make it harder to compare between. So a lot of people tend to suggest maybe just keep the order of subjects alphabetical or at least consistent. That's one thing I hear a lot from this. Choose the categories, another kind of layer of interactivity, also valid. Yeah, organize the subjects better, group similar ones to make it easier to compare. I like that idea a lot. I find it very informative, useful, easy to understand. Maybe a filter for discipline could be added. Yeah, I think it's a really fun visual. Like we're nitpicking at it right now, but it's good for what it tries to be, right? It lets you explore the data. I think it articulates this underlying point about gendered language and teacher reviews pretty well. But I do like the idea of some additional filters. Increased interactivity could be fun as well. Nice suggestions, everyone. I hope that it was helpful to kind of build this background think about dynamic data viz, again, our reasoning for doing this is we don't just want to code something up because it looks cool. We want to make sure that when we are going to the effort of making a dynamic data visualization, it's for a reason, right? That dynamic data viz is actually the most effective way to accomplish what we're trying to accomplish by visualizing that data. But now the part that you guys actually want, the coding part. We've built up our scaffolding. Let's figure out how to actually make these data viz. Way back in our introduction to visualization, we talked about, I said way back, it was last week, but it feels way back. We discussed some different tools, both free and proprietary, for producing dynamic data viz. Things like Tableau Public and Power BI. They have point and click interfaces, right? Very easy to learn, lots of resources. They offer tons of really beautiful ready-made options for dynamic data viz. If you want to play with either option for one of your assignment 3 graphs, more than welcome to do that. Today, to stick within our scope for this module, right, to keep prioritizing reproducibility, doing things programmatically, we're going to focus on learning about this package that can let us make interactive data viz in Python. Like we've been doing this whole time, we're going to talk about Plotly. So let's start by getting it all loaded up, and then we're going to go ahead and make up some sample data for us to work with. So we're going to make some categorical data, names, and then some corresponding, fake measurements for those names. Is there a way to make a conclusive data viz from this dynamic data viz? Depends what you mean by conclusive, as in like clearly conveying one message or narrative. Do you mind clarifying that? I would say it's a lot harder with dynamic data viz. If you're confident that all of your dynamic or all of your underlying data in all of its possible permutations with the filters that you're providing will, lead to the same message, then arguably yes, right? It can still be conclusive. It can still send home that message. The problem is when you're giving people the ability to explore all different aspects of your data and frame it in different ways, that message might be a little bit diffused, right? They might fixate on a different aspect of your data or filter it in a certain way. So it can be harder to convey one clear message. Not impossible, but generally a little bit harder to do. Does that answer your question at all? Thank you. Good question. Okay, let's go ahead and type this code. Scroll down past this giant chart. Alrighty. So we're going to import plotly.graph_objects as GO for graph objects. And then our x1 variable that we're going to make, numpy.array, round brackets, square brackets, and then in quote marks, we're using our same cartoon character names that we did yesterday, the day before. I think it was yesterday. And then let's make our y1 variable, numpy.array, round bracket, square bracket. And this time we'll just use our list of pretend measurements. You guys can let me know in the chat if you're able to get to this point with me, if you're having any issues or errors before we move along. Thumbs up coming in, that's good to see. Go on to the next one and you'll still be able to see this on the screen once we build into this. So we have our data, we have everything loaded. Now we can actually make our plot. So Plotly syntax is a little bit different from Matplotlib or Seaborn, but we're going to go through it together, put it together piece by piece. So we'll talk through the slides and then we'll go write our code. So first thing we have to do is make our figure object. So this thing which we're calling graph is going to be a GO, a graph object, which is a figure. So I realized last time I taught this, it says go figure, which is kind of funny, but that's what we're doing to make our figure object. Then we're going to choose our plot type and our data, and we're going to add that into our figure container as a trace. Think of a trace as our axes in our Matplotlib language. So to this object that we made called graph, we are going to add underscore trace. That new trace, again, a graph object, it is going to be a bar graph. And here are the variables that we want to use for that plot. Next, we're going to update our layout to include titles. So again, with our same graph object, we're going to update underscore layout and then add in our overall title, x-axis, y-axis title. And then finally, we'll tell Python to print out our plot for us so that we can see what we just made. So let's go ahead and type all of that out and see what we can produce. So first, we're going to make this object called graph using our graph objects. It is going to be a figure. Then to that graph object, we're going to add underscore trace. That trace is a bar plot. Note the capital there. And then our x variable is going to be x1, like we just made above. Our y variable is going to be y1, again, what we made previously. For that same graph object called graph that we made, we're going to update underscore layout. We're going to add in a title, which is pirate scores, an x-axis underscore title, which is pirates, and a y-axis underscore title, which is score. Again, noting those quotation marks around each of our words for our titles. And then let's tell Python to show us this thing that we just made. And we end up with this lovely interactive graph. You can see immediately when I'm hovering over it, different things are possible. We'll explore that all together, but I'll pause here so everyone has a chance to actually type the code and produce this. You can let me know in the chat if you can get to this point, any errors or questions or things I can re-explain before we start playing with this. And again, I hope we're seeing that even though some of the specific kind of language that we're using is different from Matplotlib and Seaborn, it works in a similar way, right? We define the data and then we can build on those different kind of aesthetic arguments and details. And we'll see in a couple slides that we can add on to that in much the same way we have been doing all along, just with slightly different language. I see 8 thumbs up. We'll wait for a few more or for any kind of questions, concerns. What do we have here? This image thing, I need to fix how this image pops up. Y equals y1. Let me see the error that you're getting. Object typeset is not. Hold on, let me. So it's something to do with how you're importing the package, I think. Kiriyoshi, if you can check up here to make sure that you're importing it in the same way that I am. And I guess, of course, that you have it installed. It worked, and you're still getting that, or sorry, the code worked, or importing it worked? Import worked, but the later one didn't work. Cindy, do you see any issues with the code? You're also getting the same error.
No, not really. Let me search online, see what I can find.
Thank you. Is anyone else getting this problem with Plotly? Because I think it was on the list of packages that you guys installed right at the beginning and setting up your environments. Go to figure, bar. Zainab doesn't see any graph. Did you type in graph.show, Zainab, to make sure that it prints out? And it's not showing you your graph. Do you mind sending in your code that you typed in the error message or whatever you're receiving, please? Oh, Rachel had to pip install NB format. Okay, so the people who are having issues with an installation, if you would like, you could please try pip install Plotly, pip install NB format, and see if that changes anything. So these two lines here, if you run those and then rerun the rest of the stuff, let's see if that makes any kind of difference to get this to work. Everyone else bear with me for a couple of minutes while we try to figure this out. If this doesn't work, then I will leave you guys in Cindy's capable hands and we'll continue on. But if it's something affecting multiple people, I just want to make sure that there's not an issue with the underlying code. Thank you, Rachel, for that suggestion, by the way. If Hiroyoshi or Aloysius, if you could let me know if this does anything for you. Still the error message. Okay, interesting. Okay, Zindi is looking up your error message, so I think instead of staying here, if you guys can follow along with me still for now on my screen, and then Cindy can help you guys in the chat to try and figure that out, so that you'll be able to run the code after long. So you guys can still type along with me, you just might not be able to run it. Let's just say I ended up using a curly bracket instead of square brackets. That will that'll do it. I'm glad there was a little typo thing. So Hiroyoshi, Zindi will be able to help you. In the meantime, you can keep typing along with me, and then you should be able to run the code once we figure out a solution to that. So yes, so we've produced our dynamic graph using Plotly. Lots of fun little features that come with this interactive Plotly plot. So you can download as a PNG. You can zoom in to a specific area. Again, here, not super relevant, but in the case where we have like a scatter plot or something, it can be really helpful to hone in on a particular region of our graph. If we want to reset, click that little home button. Auto scale, zoom in, zoom out. We can lasso select a certain region. We can hover over our bars and get different tooltips, which is nice to see. Again, in the case where we have tons of different data points or where our axes are less clear, this is a really good way of actually understanding what we're looking at. And some of those different changes are listed in the slides as well, in case you need kind of a point of reference for what's possible to do. You can also save Plotly graphs as HTML files and embed them in our web pages. I just put this example code here because I don't know the different folder paths that everyone is using. But again, simple line of code for you to be able to save the HTML file to keep that interactivity in your work. And as I mentioned, just like with Matplotlib and Seaborn, we can customize different visual elements of our graphs. This slide is just an ugly wall of code, so I'll talk through it as we're typing it out together and see how we can make this graph a little bit prettier. So sticking with what we did so far, just like with Matplotlib, we can add in some aesthetic features up here where we're kind of defining our data. So let's change it up. Let's make it a scatter plot. Our x is still an x1, our y is still a y1. But let's add in mode equals markers. We want individual points. Let's change the appearance of our markers by making a little dictionary. So we want our marker size to be 15, our color to be hot pink. Can you guys tell I like pink from this class? Our opacity will be 1, so 100%. And then we can also say we want a line connecting our points. And then another dictionary. And for that line, we want our line width to be 5 and our line color to be purple. And then let's go ahead and customize some things about our graph layout as well. So we have our title, we have our x-axis title, our y-axis title. We can change our plot width to 500 pixels and our plot height to 500 pixels. Run all of that, and now we have this square graph with our points being pink, the line around them being purple. We still can hover over our points to see what's up, but we've changed the dimension of our plot. Again, just a few little changes. So slightly different syntax than we might have used with Matplotlib, but overall similar enough to see. So let's chat. You guys can let me know if you're able to get to this point. See Zindi helping out still. Thank you very much. If you have any questions about what's happening here, you could ask me. We still have all of our fun interactive features, and everything is still nice and reproducible. Do a thumbs up. Any issues, any questions? When we hover on the markers, we get the coordinates. Are those an automatic feature of Plotly? Yes, they are. I don't know off the top of my head. I can look in the documentation to see if there's a way to modify how these tooltips look, but they do just automatically appear as part of Plotly. But if you'd like, during office hours, I can do some Googling and see if there's a way to change how those tooltips appear. You might just have to remind me because I will forget in the next 10 minutes. Good question, though. See 7 thumbs up. I'll just give it a couple more minutes in case we have any issues, concerns. All right. So we've seen Plotly. We can produce a nice dynamic data viz still with our reproducibility, which we really love and prioritize. Next stop on our kind of bird's eye tour of expansions and advanced data viz in Python, we can visit qualitative data viz, by which I mean things like word clouds and Venn diagrams. And again, we have addressed this before, but it's a valid question. Why are we bothering using code to make a Venn diagram or to make a word cloud, things like that? The benefit of doing it in code, it's not that much harder than using, you know, an online tool, something like that. But if we put that little bit of extra effort in, it's reproducible, we can edit, we can assess and change what we've done. So it's worth that little bit of extra trouble to have that flexibility. So starting with word clouds, part 1, we got to import our package that we're using. And then we're going to need a whole bunch of text data in order to make a word cloud. So we're going to load up this convenient movie quotes data set from GitHub. I will send the link in the chat because it would be cruel to make you type all that. And it's a link to basically raw CSV data hosted on someone's GitHub. we load it just using this read CSV function from pandas. This line here on bad lines equals skip. We're just making sure that we can load our data here without it breaking. Also perhaps a useful line of code if you're trying to load in data for assignment 3, your last assignment, read_CSV is a very useful package to know how to use. So let's try writing all that out. So from word cloud, lowercase, we want to import word cloud with uppercase W and uppercase C. And then we're going to go ahead and load in our sample data. So we're making this thing called df for data frame. From pandas, we're going to read_CSV. And then in quote marks, we're going to paste that URL without the bullet point, like I just pasted. Whoops. And then still in our brackets, I'm going to put a comma. And then we're going to say on_bad_lines equals skip in quotation marks. And then let's print out this data frame object that we just made. And we see that we get this table, which has quotes, the movie they're from, if it's like a movie or a show or what it is, and what year that thing came out. So let me know if we're able to get to this point, if we're having any problems. There's a bunch of thumbs up right off the bat. And again, the key thing to point out here is when you're trying to open a CSV or something from GitHub, it has to be the raw CSV. Because if you try to pull in with the formatting, it'll get all weird. We are converting raw data into a data frame. Yes, exactly. So we're saying take this CSV and turn it into a pandas data frame for us to work with. 9 thumbs up. We'll wait for just a couple more to come in, or for any questions or issues. To no module named word cloud. Did you install it earlier with our pip install word cloud? I lost it in the chat. Who was that? Zainab, if you pip install word cloud, then you should be able to run the rest of it. Thank you. Oops, I accidentally closed it. Okay, there we go. Let me make sure I'm not missing anything in the chat. Okay, perfect. Cool. So we've pulled in our data. We see that it's quotes, plenty of text for us to work with there. All we're going to do is walk through this code together and make ourselves a nice little word cloud. All the comments about each line are in the slides, but we'll talk through it as we type it out. I think that's a comfortable way of doing it. Some more coding squares for us. So the first thing we want to do is we want to say that we're using our quotes column from our DF dataset, and we want to join all of our text from each row in that column into a string. So we're saying this thing called text. So quote marks with a space in between, period, join, bracket, each for each in DF quote. So again, we're joining up all of our quote data into a string separated by this little space. Next, we have to tell Python, okay, I want to make a word cloud image. We're going to define our background color, the color map of our text. So we're going to say, make this thing called word cloud using our word cloud with the capital W, capital C function. The background underscore color that we're using is going to be white. The color map we're using is Inferno. And again, that's something that comes with the word cloud package. If you look at the documentation, it'll tell you your options. Then we're going to generate this word cloud for this text variable, right? This string of all of our quote data that we made. And then back to our old friends, we'll use our matplotlib syntax to take this thing we just made and put it into a figure. So we're going to make a figure with an axis object inside using our plot.subplots, our figure size. Let's make it 7 by 3. And then to that axis object, remember when we learned how to add an image to our plot, ax.imshow. We're going to take that word cloud object that we just made. Interpolation equals bilinear. This one makes our image look smoother. Here we don't really see a difference. If we have a huge giant data set, then it's kind of helpful, so we just include it as good practice. And then remember, we also want to say for that axis object, let's turn our axes off. We don't want to see all those tick marks and things like that. And when we run this, we can see that we have produced this lovely word cloud. So the bigger words are the words that occur most commonly in that quotes data set that we pulled in from GitHub. So let me know if you guys are able to get to this point. If you have any questions that I can explain about what's happening here. And again, I think word clouds are one of those things where, you know, maybe they don't appear in a peer-reviewed data science publication or report, but for more public facing or as a scene setting or context for your exploration of your text data, I think they're a really nice visual tool for kind of easily highlighting recurring words or phrases or themes. They're an effective and kind of easy to interpret and also visually interesting thing to be able to produce. You see 6 thumbs up. That's a good sign. Yes, so interpolation equals bilinear. I lost it in the chat. So here for our data set, it doesn't matter too much. When we have a case where you have like a giant data set with tons of different, like here we have clear, right? No is really big, love is really big. When we have a giant data set with less clear trends, this is something that helps our image to appear a little bit more smooth and less kind of jagged and messy. So here, if you remove it, you won't really see too much of a difference. But in general, it's a nice thing to include in the event that you're working with like a giant, huge data set. It does produce a different image. Do we need to, will it change if you set a seed above that? This is an issue that we've had before, but it's basically, it's the same underlying data, but the changes, the actual image will change slightly. This is an issue that we've come across before with this package. Thank you, Imran. Good question. I lost the thumbs up in the chat, but I think I saw, oh, we got like 10. We're good. And again, right, not too much extra work to do this in code versus using some kind of online tool. But because of this, we can go in and see exactly what we did with our data, how we're kind of processing it, and how we generated this image. So that's one of our qualitative viz. The next one that we're going to cover is Venn diagrams. To do this, we're going to use our matplotlib Venn extension. So it's more stuff kind of built on top of matplotlib. I think we can tell by now matplotlib is really, really central to data viz in Python. Even the other packages kind of use it as a baseline. So let's try and get all of that loaded. We'll do that first, and then we'll get into building out our data. Whoops. There we go. So from matplotlib underscore Venn, we are going to import Venn2 underscore circles, and Venn2 underscore unweighted. I'll pull this back up in just a second. But our next step, once we have that installed, is to define our sets. So the stuff that we want to actually display in our Venn diagram. So for simplicity, we're going to call them A and B, and they're going to be different kind of fruit flavors. Note that these two sets are different, but apple is in both sets, right? It's in both lists. So let's go ahead and build out those sets for us. So set A is a set, round brackets, and square brackets inside that. It contains apple, banana, and watermelon. And then B, again, it's a set, so round brackets, square brackets, and it contains pumpkin, blueberry, apple, and key lime. We'll run that, and then you guys can let me know in the chat if you're able to get to this point with me. Or if you have questions, I'm happy to explain differently or answer what's happening here. So we have our package loaded. We've built our sets, right? Our underlying data that we want to show. Now let's actually build our Venn diagram. So we need to assign our sets to each circle of our Venn diagram, and we want to modify what it's going to look like. So let's make this object called diagram using our Venn2. So in round brackets, we'll put square brackets, A and B, right? Those are our two sets that we're using. Let's set underscore labels. And then in brackets, we're going to call our A circle fruits and our B circle pies. And then let's set underscore colors. And the colors we're going to use are blue and red. And then one more change to our appearance. We'll set alpha equals 0.5. And alpha is how we change our transparency of our points. So this is like 50%. We want them to be 50% opaque. So if we just run this, we get a Venn diagram and it has the colors that we want. It has the sets that we want. But by default, this package only shows us the counts in each section of our Venn diagram. So like there are 2 things in this category, 1 in both, and 3 things in this category. We want it to actually show us text, right? To list out the different fruits and pies that are in each section. So the thing that we're going to do here is assign the text content of each circle. I'm going to type out the code and then I'll explain what some of the weird looking numbers mean. So to our diagram object that we just made, we are going to get underscore label underscore by underscore ID. And then in brackets, quote marks, 10 dot set underscore text. And then in brackets again, quote marks, backslash n dot join, more brackets, A minus B. That's one line. I'm going to put the comment here. This is our left circle. Again, we're going to type diagram, get, label, by ID. This time in our brackets, we're going to put 11, 1, 1. We're going to set underscore text, quote marks, backslash n, dot join A and B this time. Middle slice. Again, I'm going to explain this all after I'm done typing it. Same thing again, get label by ID. This time it's 0, 1. We're going to set text in quote marks, backslash n, dot join, bracket B minus A. And this is our right circle. Ooh, I can't type. Okay, let's talk about what's actually going on here. So I think the confusing part here is the numbers. It's not 10, 11, 0, 1. It's 1, 0, 1, 1, and 0, 1. So 1, 0 is referring to this circle on the left. So it's like, think it with binary. So 1, 0 is this one, 1, 1 is both, and 0, 1 is our circle on the right. All we're doing back here is saying that the text that we want in that particular circle is we're joining things that are in list A and not in list B. And we're joining those by a new line character. So for every item in that list, we want it on a new line. This new line character is this \n right here. For the middle, we're saying that the text that we want is the things that are in both set A and set B, again, joined by a new line. In this case, we only have one, so it doesn't really matter. And then for this right circle, we're saying take the things that are in set B and not in set A and join those and separate them by our new line character. And then we end up getting this lovely Venn diagram. Let me scroll up so you guys can see that. You guys can let me know in the chat if you're able to get to this point, if you have questions, if I can explain anything again. I know that was a lot of typing specific stuff. Cindy, thank you for answering the question about alpha. I got 6 thumbs up. That's nice to see. I'm impressed at myself for not making as many typos as I usually do when typing this one. Isolate the ID. Is it always 0111 or 0111? Yes. So think of it as it's 2 slots, right? Slot 1 and slot 2. For this circle, we're saying this circle is a 1 because it's present. This circle is a 0 because we're not thinking about this circle here. For the middle slice, this one is a 1 and this one is a 1 because they're both being considered in this slice. And then this one over here, it's a 0 because this circle isn't considered. It's a 1 because this circle is being considered. Does that think of it as like switches going on and off? Thank you. Thank you. Good question. See 9 thumbs up. Just a couple more minutes. We'll see if anyone has any issues, concerns with this one. And again, this is a more qualitative kind of data viz, but it's really helpful as a kind of comparative tool, demonstrating a point, background concepts for maybe some more complex statistical analyses or data visualizations. A nice thing to have in the toolkit of data viz that we can make. Anoop, yes, I think so, but this package I think also has a thing for 3 circles where it's not all side by side, it's 2 and then 1 like that. So I don't know the syntax off the top of my head, but I can find the link to the, let me check. Do I have it in my notes? I think I might have it in my notes actually. Yeah, maybe. I don't know if this link is still working, but I think that's the link to the documentation for Matplotlib. So it should go through in disgusting amounts of detail, all the different things that you can do with this package. Let me know if that link is broken and I'll find a better one. Is circle scaled per the number of elements? Yes, exactly. By default, it does that. I'm not sure if there's a way to change that. If there is, it'll be in the documentation that I sent. But let me know if you want to look into that and I can find something during office hours or do some digging to see if that's possible. Okay. I'm not seeing any incoming questions. I think you use Venn2 unweighted. Ah, perfect. Let's try that. Is deprecated. Yeah. So it still works, but it's not the most current with the appropriate layout algorithm. So I'm assuming this layout algorithm is an argument that we can change, but for now you can use Venn2 unweighted. All right. Thank you, Arzana. Good suggestion. If we're feeling okay about our qualitative data viz, word clouds, Venn diagrams, so on, then that's a ton of new concepts for one night. So we'll stop with the new content. The last thing that I want to do for today, oh, it's on the slides, perfect. Thank you, past me. The last thing that I want to do is remind us for this upcoming Tuesday, we'll do our review, our wrap up, engage with some concepts a little bit, all that fun stuff. We'll do a little bit show and tell of your assignment 3 visualizations because you guys deserve to brag about the things that you were able to produce. But the most important part about Tuesday's class, we have our industry guest speaker coming in. I'm Ntese, a working data scientist. I always feel really lucky that we have these data scientists willing to come in and give their time to our class. You've all been really, really great at engaging with me and my 10 million activities throughout this last month. So I really, really encourage you to continue doing that for one last class on Tuesday. Ask questions after the presentation, be welcoming and attentive for this person, volunteering their time to teach us some really cool stuff, to show how all of the stuff we've been learning actually applies out there in the real world. So I hope that you're all able to be there on Tuesday, engage with our guest speaker, ask those questions, benefit from that presentation, and end off our data visualization course in a fun way. That's it for me for right now. Thank you so much for your work today and throughout this week. You've all been doing such a wonderful job. One last class on Tuesday. Until then, enjoy your weekend. Remember that your last assignment is due Sunday night. Please try to get that in on time if possible. Use your work periods if you need any help with writing that code, figuring out how to make it. You also have office hours with me for now if anyone has any immediate questions. Have a good night, everybody.